Use the central limit theorem for means to find probability. Now, the central limit theorem for means to find probability, we are basically saying, okay, let's say we know the population mean and standard deviation, right? We know the population mean is mu, standard deviation is sigma. Well, if we know this information, and we say, okay, well, how does that relate then to a sample of that population? So we're getting into the mean of that sample population, which we would call mean sub x bar. And the nice thing is the mean of the population is generally equal to the mean of the population of the sample, or the sample, the mean of the sample. Whew, words are hard. Now, the standard deviation of the population, and then when we talk about the sample of the population, we sometimes call it the standard error of the mean, and we note that as sigma sub x bar, which is found by taking sigma divided by the square root of n. So a lot of this depends on, as you can see, n, the sample size. Now, z-score, when we think about the z-score, we know, right, in the past we take value minus the mean over the standard deviation. That's our standard way of finding a z-score. Well, now, because we are dealing with a sample of that population, our z-score is found by taking x bar, right, the value, minus the mu sub x bar divided by the standard error of the mean, which would be the standard deviation divided by the square root of n. So if you're putting this in your calculator, I would recommend parentheses. So this right here, right, is one of the things we're going to need today. So, according to a recent study, the mean number of hours spent watching TV per day is 3.17, with a population standard deviation of 2.87 hours. A new researcher thinks this is too high and decides to do a new study of 60 randomly chosen people. What is the probability the mean number of hours watched is at most 3 hours per day? Now, if we think about a normal distribution, now the mean is 3.17. We know the mean is in the middle. That means 3 is over here. At most 3, we're talking at most 3 is 3 or less. So we are trying to find the shaded region, right? Probability is area under the curve. So to do that, we need to first find a z-score. Well, because we are dealing with a sample, we're dealing with the central limit theorem, so we know that this is the same as mu sub x bar. We also need to find our standard error, which means we will take 2.87 divided by the square root of 60, which comes out to be negative 0. Oop, nope, I lied. That's my z-score, so sorry. I didn't calculate that. That's the formula there. Okay, sorry. Now, let's move on to the z-score. So I know from before my formula is x bar minus mu sub x bar over sigma over, we'll just put sigma sub x bar down here. Okay, make it a little bit easier. So let's plug in what we know for our z-score. We are saying less at most 3 hours. So that is our value of x. So 3 minus our mean, which is 3.17, divided by our sigma sub x bar, 2.87 over the square root of 60. Now again, as I mentioned earlier, you're going to want to put your numerator and denominator into parentheses if you're plugging that into your calculator, and that's where we get a z-score of negative 0.46. So I go to my table, or you might be using a calculator. So our z-score table, here's negative 4, here's 0.06, so this is my value right here. So my probability of x being at most 3 is 0.32276, or roughly 32.276%. All right, let's do one more of these. Assume a population mean is 26 with a population standard mean, mean 26, population standard deviation of 2.8, excuse me. A sample size of 35 is randomly selected from the population. Find the probability the sample mean is between 24 and 28. Again, we know the mean is in the middle. So now we're finding this area between the curve. So again, we know this is the same as mu sub x bar. we know that sigma sub x bar is 2.8 divided by the square root of 35. So I don't need to use these anymore. But we're going to need to find two different z-scores, right? I need to find the z-score when x bar is 24, and I need to find the z-score for when x bar is 28 so that I can find the area between those two values on the curve as shown here. So to do that, let's go ahead and say, okay, so we'll call this z1 when x is 24. So 24 minus 26 all over 2.8 divided by the square root of 35. When I plug that into my calculator, I get a negative 0.42. Now, funny thing how this works is that when I do z2 and I do 28 minus 26 over 2.8 divided by the square root of 35, well, that's a positive 4.42. Okay. So these are the z-scores. So the first thing that I'm going to do is find the area to the left with a negative 0.42. So let's go back to this and say, okay, here's negative 4.02. So where do they meet? Right here, 0.33724. So this area here is 0.33724. Now, I'm going to find area to the left of the 28. So that's a positive 0.402, 0.66276. Oops, wrong direction. So this teal line is 0.66276. Now, if you'll notice, when I drew these lines, everything to the left of this line is overlap. So when we have overlap, we can subtract, because if I subtract, the overlap is what goes away, and I will just be left with the area under the curve. So I'm going to take 0.66276 minus 0.33724. And when I do that, so again, I'm finding the area between 24 and 28 by subtracting these two values and getting rid of the overlap. The area between the curve, when I subtract, again, 0.66276 minus 0.33724, I get 0.32552. And that is the area under the curve. So that's roughly 32.552% probability. Thanks.